Hello everyone and welcome to this video lecture. My name is Ram Sahu and I am from Department of AI/ML Technocrats Group Bhopal. Today I want to discuss about a important data structure, that is queue. This lecture contains basic principles of queue, operations on queue, using array, representation of queue using linked list, applications, advantage and disadvantage of queue. Queue. A queue is a data structure that is fundamental concept in computer science used to storing and managing data in a specific order. It follows the principle of first in, first out, where the first element added to the queue is the first one to be removed. It is used as a buffer in computer systems where we have a speed mismatch between two devices that communicate with each other. For example, CPU and keyboards, and two devices in a network. Queue is also used in operating system algorithm like CPU scheduling and memory management, and many standard algorithms like breadth first search of graph and traversal of a tree. Basic idea. Queue is an abstract data structure similar to a stack. A queue is open at both its ends. One end is always used to insert data. That operation is also called unqueue, and the other is used to remove data. That end is called dequeue. Here, a array is shown in the form of queue where two ends are consist, that is the front and rear. Basic operations on queue data structure, that is enqueue, that means insertion of element to the queue, dequeue, that means removal of elements from the queue, get front acquires the data element available at the front node of the queue without deleting it, get rear, this operation returns the element at the rear without removing it, is empty, check if the queue is empty, and size operation, this operation returns the size of the queue, that is the total number of elements that contains. First one is the array implementation of queue. For array implementation, there are many operations that are performed by a queue. As in a stack, a queue can also be implemented using array, linked list, pointers, and structures. Queue is a first in, first out type of, as we know, it works on first in, first out, where first element to be inserted, removed first. These are the different operations. This is the linked list representation of array, linked list representation of queue, where first node works as a front node and last node works as a rear node. New node insert only on rear and the node to be deleted from the front. Another version of queue is the circular queue. A circular queue is the extended version of a regular queue where the last element is connected to the first element. A circular queue is a linear data structure that overcomes the limitation of queue. In a normal array implementation, the queue can be big of n or more space. Using a circular array, both enqueue and dequeue operations can be done in the big O of one time. Declaration using array. In this implementation, array is used to store elements. Different operations of circular array, enqueue and dequeue. Enqueue, that means insert an element x at the rear of the circular queue. Before that, check for full queue. If size is equal to capacity, the queue is full, print messages are written. Compute rear index, rear is equal to front plus size mod capacity, ensure circular behavior. Insert element at array's rear position, that is x, and then update the size of the queue by 1 by increment of that. Time complexity for n queue is big O of 1. Space complexity is also big O of 1. Day queue, that is means remove and return the front element from the queue. For this, first check the empty condition of a queue. If size is equal to 0, that means queue is empty and message or return -1. Retrieve from element, that is the array front. Move forward by front +1 mod capacity, circular movement. Update the size, that is decrease by 1, and return res. Here the array representation of NQ and DQ operation shows. Initially front and rear, and rear is equal to 0 and Q is empty. We can insert one by one elements from first position to last position. When all the elements in all the places are inserted, the queue is full condition, and then we want to insert a new item. It cannot be possible because queue is full. Similarly, DQ operations are performed in this full queue. One by one, each element can be deleted. If there are no element, no deletion operation can be performed. Application of circular queue, CPU scheduling. Circular queue manage processes in round robin scheduling, ensuring fair CPU time allocation. Data buffering, used in streaming data applications. Resource management, manages a pool of resources like printer or network connection, where resources are allocated and released in a cyclic manner. Traffic management, manage packet routing in networking. Next variation of the queue is double-ended queue, that is also called DAQ. DAQ or double-ended queue is a generalized version of queue data structure that allows insert and delete operations at both the ends. Here operation shows in the array form of the DAQ, where both end works as a front and rear operations, add of element and remove of element from front end as well as rear end. DAQ can act as both stack and queue. It is useful in many problems where we need to have a subset of all operation also, like insert, remove, front, and insert or remove at the end. It is typically implemented using a doubly linked list or a circular array. Implementation of DAQ using circular array, that insert, delete, create, initialize, inserting elements, removing elements, they perform different operations. These are the circular array represented, where initially front and rear are the 0, and after that one by one element can be inserted. Implementation of DAQ using doubly linked list, where we use double-sided linked list that contains 2 pointers, left pointer and right pointer, and information field. Operations on DAQ, that is the insert front, insert rear, delete front, delete rear. Additional operations are supported by this DAQ: get front, get rear, is empty, size, and erase operations. Application of DAQ, it is used in job scheduling algorithms. It supports both stack and queue operations. The clockwise and anti-clockwise rotation operation in DAQ are performed in big O of 1 time, which is helpful in many problems. Advantages: you are able to add and remove items from both the ends, front and back of the queue. DAQ are faster in adding and removing the elements to the end or beginning. The clockwise and anti-clockwise rotation performed are faster in a DAQ. Dynamic size: DAKE can grow or shrink dynamically. Efficient operation that perform efficiency, that is the big O of one-time complexity for insertion and removing elements from both the ends. Versatile, no reallocation, thread safe, case friendly. Disadvantage of DAKE. DAKE has no fixed limitation for the number of elements they may contain. This interface supports capacity restricted DAKE as well as the DAKE with no fixed size limit. They are less memory efficient than a normal cube. There are certain other disadvantages are memory overhead. DAKE has higher memory overhead compared to the other data structure. Synchronization. DAKE can cause synchronization issue if not used carefully in multi-threaded environment. Complex implementation. Implementing a DAKE can be complex and error-prone, especially if implementing it manually. Not all platform DAKE may not be supported by all platform and may need to be implemented manually. Not suitable for sorting. DAKE are not designed for sorting or searching. Limited functionality. DAKE have limited functionality compared to the other data structure. Next version of the queue is the priority queue. A priority queue is a type of queue where each element is associated with a priority value and elements are served based on their priority rather than their insertion order. Elements with higher priority are retrieved or removed before those with lower priority. When new item is added, it is inserted according to its priority. The binary heap is the most common implementation of a priority queue. A mean heap allows quick access to element with the smallest value. A max heap allows quick access to the element with the large value. Binary heap are complete binary tree, making them easy to implement using. This is the priority queue in data structure example given, where information field contains front end there, two ends are there. Priority also associated with each element and the lower is the index of that elements. NQ and DQ operation can be performed both the ends as per the priority of that particular element. Types of priority queue. There are two types of priority queue. That is the mean priority queue, that is also called ascending priority queue. And second one is the max priority queue, that is the descending priority queue. In ascending priority queue, in data structure, elements with lower values are considered higher priority. This means that when dequeuing, the smallest value is removed first. The priority is inversely proportional to the numerical value of the element. Second one is the descending order priority queue. In a descending order priority queue, element with higher values are given precedence. This means that the largest value is dequeued first. The priority is directly proportional to the numerical value of the elements. Implementation of priority queue using max heap in heap. Max heap consists maximum value at the root element and min heap consists minimum value at the root element. Applications of priority queue. Some of the application of priority queue are Dijkstra's algorithm for finding the shortest path. For implementing stack, we also use priority queue for load balancing and interrupt handling in an operating system, for data compression in Huffman code. Advantages of priority queue: efficient access to highest and lowest priority element. Priority queue allow to quick retrieval of element with the highest or lowest priority, typically in big O of one time, if implemented with a heap. Dynamic reordering, they can efficiently handle changes in element priority dynamically, reordering themselves to maintain the priority hierarchy. Wide range of applications, scheduling, CPU scheduling, task management in operating system, etc. Graph algorithm like Dijkstra's algorithm, Prim's algorithm for finding minimum spanning tree, simulations, event-driven simulations, data compressions, that Huffman's coding methods. Disadvantage of priority queue, higher complexity than basic structures. Priority queue are generally more complex to implement than simple queue or array, often requiring a heap or balanced binary search tree. Increased memory usage, storing priority information alongside data element can lead to higher memory consumption, potential for starvation in scenarios with continuously arriving high priority tasks. Lower priority tasks might face indefinite